All right, so today we are talking about the ERD lesson. So ERD, everybody did I know you all did the reading. So what does ERD stand for? All right, that's cool. ERD stands for entity relation diagram. So you'll hear me say ERD diagrams. I realize that's a redundancy, but I'm in the habit of saying it. So ERD, so we're going to do a quick overview. So up to this point, Ed taught us the front end, right? So we talked about HTML, CSS, JavaScript. So that's the front end. And last week we started talking about the back end. The back end is what allows us to communicate with the front end. We make a web server that will respond to requests from the front end and send data back. Okay, so last week we left off with we got up to the first two pieces of the puzzle. And today we're going to talk about the final piece of the puzzle, which is databases. Okay, so databases, at this point, like without databases, our only option for saving data or persisting data is sessions, right? That's the only way we could store data. And sessions rely on the browser's storage. So if one of our users clears out their cookies, then the data is gone. So our database will allow us to persist data and to manipulate it and basically make our user experience better. We can remember our users between sessions and keep track of their data. Okay, so that sort of begs the question, what is a database?
The base where data is held.
A base where data is held. Awesome. That is probably one of the best circular definitions I've ever heard. That's awesome. A base where data is held. So probably the closest analogy that we all have to a database is a spreadsheet, right? So you guys got to get on your assignments, by the way. I'm just kidding. But this is our spreadsheet that we use to keep track of our assignments, right? So this is it's not a database, but you can think of a spreadsheet as a table in a database. Okay, so our tables in our database are pretty much going to look identical to this. They're going to have rows that go across. They're going to have columns that go down. And the only difference is in terms of volume, really. Okay, so the reason, or you might have the question, why don't we just use a spreadsheet, right? Why go to the trouble of making this, using a programming language and accessing data using this antiquated programming language is SQL that's actually older than me. It's a year older than me, if you can believe it. So why not just use a spreadsheet?
Because the coding in Excel sucks.
Coding in Excel sucks. Yeah, well, yes, but so imagine we have we have this spreadsheet that we use. There's only 19 of us, right? That's pretty manageable. What if there were 1 million students in this class, right? Which isn't uncommon for a database to have 1 million entries. So if we had a database with 1 million entries, if you needed to go through and manually scroll through it, right? It would take you about 2 weeks to go through all of them because there's 1 million seconds in about 14 days. So just in terms of the volume of the data, we need a database to handle huge volumes of data, and also a database is much faster, much more reliable. Like we're using Google Sheets, so I can see like when Ed's doing an update, but to make sure our data integrity is secured or preserved, we want to use something like a database, okay? All right, so why MySQL and database design? So MySQL was developed in 1995, and if you're curious, the My comes from the developer's daughter's name. When MySQL was acquired by, I think it was Oracle or Sun, one of them, he created another database called MariaDB, which is named after his other daughter. So that's where MySQL comes from. MySQL, this is a recent poll from Stack Overflow. In terms of database popularity, MySQL, over half of all developers prefer MySQL. Postgres, which is another SQL database, is in a distant second. So MySQL is very popular. I don't know like the numbers in terms of like how popular, but I know WordPress uses MySQL, and I think like 40% of all websites are WordPress sites. So it's very heavily used, and I think it's a good entry point. It's a good way to get started.
There's like a couple Couchbase elitists out there.
Right. Less than 2% like Couchbase, right? And
Yeah.
so also MySQL, there's another type of database called NoSQL, which is more like using a dictionary or an object to store data. What can be stored in data is sort of up to the user. A couple of years ago, the NoSQL databases were like exploding in popularity. Everybody's like, oh, we don't have to write SQL anymore. But it seems like the SQL databases are making a comeback, or that they're still extremely popular. And NoSQL is actually, it's not no as in no, it's in not only. So apparently I've never done it, but you can still, there's a way to write SQL statements using a NoSQL database. But we're going to start with SQL because I think it's a good entry and a good way to get started. So in essence, databases allow us to persist our data. And you'll hear that term. Persist just means make it permanent or keep it secure. Okay, so databases also allow us to create, save, and manipulate data. So we're gonna next, I think it's Wednesday, we're gonna talk about CRUD, which basically means create, read, update, and delete. So with the data that we save, we want to be able to add users or add objects or add bank accounts, whatever it is. We want to be able to add them, update them, delete them if we need to, and just manage them. Okay, so the goals when we are creating a database are to minimize repetition and to minimize data queries. Okay, and queries are basically the statements or the code we execute to access our data. And I want to caution you now that minimizing repetition, it's possible to take it to an extreme. We don't need to worry like about extreme, like we don't ever want to repeat our data, right? We're going to have some repetition, but the goal is to minimize it as much as possible. And that just makes our databases faster, basically. Any questions so far? Okay. So Coding Dojo teaches ERD first. And the reason is it allows us to use a tool, and we're going to use MySQL Workbench, that allows us to basically drag and click and type into boxes, and it will write SQL for us. Okay, so the SQL that we use to create a database can be somewhat complex. It's long, so the more code you write, the more prone it is to errors. So ERDs basically allow us to use a graphical interface to write, that will write code for us. So again, ERD stands for Entity Relationship Diagram. And they're basically a visual layout of our databases. Okay, so it's a map of the structure of the data. We are able to define relationships between data, which we'll talk about relationships shortly. So this is basically an example of an ERD diagram. And these represent our tables, right? So we would have, if we have a table of authors and a table of books, and then we want to keep track of which author has favorited which book, we would have what's called the join table. And again, I'll get into more detail about this, but what these allow us to do is basically we can point and click, create this, define our parameters for our data, and then we just click forward engineer, and SQL Workbench will make the code for us and generate our databases. Okay, so it's kind of a cool tool, and it's allows us to move faster and get to the more interesting stuff other than writing SQL statements. Okay, so this is a direct quote from the platform because I couldn't have said it much better. So learning the design of the database first will help us visualize what our relational databases look like, which makes it much easier to choose the SQL syntax. So it's sort of a tool that we use to help visualize and help learn like what the relationships are without the code sort of getting in the way. All right, questions so far? All right. So database design. So we have a couple principles that we follow for database design. Some of these are on the platform. Some of these are just my personal bits of advice. So we want to try to reduce repetition, but again, don't take it to an extreme. A little repetition is okay. We want to have a table for each real world object. And I put an asterisk next to object because I want to say that I'm using the term object loosely. So we would have, like if we have a user and we have posts, we would have a user table, a post table, but the object also could represent the relationship between the two. Okay, so like with the diagram I just showed you, there's a table in between. So the object, the real world object, each one has a separate table. And then, but the relationship can be a table as well. Questions about that? All right. So each column of the database or the database table represents one attribute of our object. Okay, so if we have a user, we'd have a separate column for the first name, a separate column for the last name, separate column for the email. So each attribute, just like as if we were making a class in Python, the attributes we add to our class, each one of those attributes would be a separate column in our database table. Okay. When we first design our database using the ERD diagrams, we want to decide what the relationships are between the tables or the objects. So we'll get into the relationships. We'll talk more, go into more detail about what relationships are possible. But for now, this is sort of the basic overarching principles we're going to follow when we create our databases. Okay, so this is an example of a database table. Sorry, so this would be a users table. I took this directly from the platform. I don't know why Mr. Nibbles and has the last name of Pancake, but so this right here, and I'm using a new tool, so please bear with me. There we go. So this is the ID. Okay, so this, every time we create a table, we're going to create a column for the ID. So can anybody tell me why we do this? Why do we need to number basically our data?
It needs to be unique.
Exactly. There could be two James Benuras, right? There could be two Robert Andersons, right? So if that's the case, we want to be able to distinguish between them. So each time we create or add a row of data to our table, it's going to be assigned automatically a unique and auto-generated, auto-incremented ID value. So in this table, if we were to get rid of Adrian Dion, right? If we were to eliminate him from our database, right? Just delete that record, there would never, ever, ever be another ID1, right? So ID1 has been used, it's gone. So to avoid any confusion, anything that's deleted, the ID is gone permanently. So we don't have any data collisions or mix-ups in our database. The IDs are unique. Does anybody know what they're called? There's a special name for them, for the IDs.
Primary keys.
Yeah, so we call it the primary key. And the keys are important because they will allow us to link our data as we get into more complex data structures and tables. Okay, questions so far? Okay. So also the created at and updated at, we're going to add this to every single database table we make. There are some frameworks that require you to use created at and updated at, like Ruby on Rails. You would have to have this in every table you made. So those will just be added automatically, and I'll show you the syntax for that when I do the demo. Okay. I'm going to quickly talk about, oops, let me get out of this. I'm going to quickly go over the database relationships, and then I'm going to do a demo on how we use SQL Workbench. All right, so the relationships, really fast, one-to-one. One-to-one basically means each item has one object, right? So in this case, one-to-one, each person has one object. So in a one-to-one relationship, we're basically splitting up the address, where we're separating the address into a separate table, and we're going to keep track of the addresses in a separate table. So can anybody tell me the difference between like just having this, right? Whoops, sorry. Why not just leave the table together? Why not just put this here? I mean, it looks a little better to have them in separate columns, but why don't we just keep them attached?
For like sorting and organizing purposes.
When you get to that address, that's a bigger object, and you might not want to do the same kind of iteration with that as you would their names, maybe.
Yeah. The point I'm basically driving at is one-to-ones aren't very common. So when a one-to-one is, that means you have one thing that has exactly one thing. I can think of like one or maybe two relationships that exist in the real world that are one-to-one. I can think of a person and their social security number. I can't think of like that, like, unless anybody can enlighten me. I can't think of any other relationships that exist. Maybe, okay, so maybe the person and their email is one-to-one, but other than that, they're kind of hard to come by, right?
A parent and a child.
A parent can have many children.
How about like facial recognition data? Is that something like
Yeah. So yeah, getting
the
crazy like that.
fingerprint of your face?
Fingerprints are still, I think it's only like a 1 in 50,000. So yeah, fingerprints. So things like that, we're not going to keep track of fingerprints in our databases, right? So in terms of like, not like artificial intelligence and, like data or forensic science, right? There's really very few one-to-one relationships that exist. The one thing I want you to take home from this is the existence of the foreign key. So the foreign key is basically how we link tables together. Okay, so in this case, they separate out the address into a separate table, and then we create this address ID, which links the two tables. So the only link between, like the way we link Randall Frisk to his address in New York, is because this address ID corresponds to the primary key on the address table. Okay. And I'll talk more about foreign keys and primary keys, but just know that the way we link tables, once they're separated into two tables, is we look at to see which foreign key corresponds to the primary key on the table that we're linking. So these two are linked. And the short of this is, my advice, I guess, regarding one-to-one is this. Anybody know what this stands for? YAGNI. Stands for you ain't gonna need it. So the only time what you can use a one-to-one for, the only like real world example I can think of would be like if you have users and you want to separate out data to keep it secure and private, you would separate the users like social security number, address, and all that stuff into a separate table. So like maybe the employees of an organization can't see a user's personal data. That's the only reason I can think of a use for one-to-one. And you're not going to be tested on it. So just know that it's possible to make them, but This is probably the last time you're going to see a one-to-one. Okay, questions so far? Okay. So by far the most common relationship we're going to see is one-to-many. So one-to-many, most common. So this is just the one-to-one, the customers with the addresses. But if we talk about orders, right? One customer will have many orders. Okay, so we would keep track of the orders that belong to a customer. Well, let me ask, how do we keep track of the orders that belong to a customer?
Relate them to the customer ID.
Right. So we create a customer ID to link the two. So if we have a customer ID, this is going to link the orders table to our customers table. Okay. So how many orders does Randall Frisk have?
1,
One. How many orders does Michael Choi have?
2,
Why 2?
because he's noted twice for ID 688 and ID 689.
Exactly. His name or his ID, his customer ID, appears twice. So we know that Michael Choi has 2 different orders. Okay. When I was learning this, I was perplexed and confused by how to establish, like, where do I put the foreign key, right? So the sort of rule of thumb I came up with was, if it belongs to something else, then it gets the foreign key. So I kind of thought about like branding an animal, right? So if you just, a farmer will establish their relationship or the ownership of an animal with a brand. So that's kind of the way I visualized it. And you guys are probably maybe smarter than I am and be able to figure this out. But I was confused as hell as to how I established like where to put the foreign key. So if it belongs to something else, it gets the foreign key. Okay. Questions about that? Is it making sense? How many? So let me just get a quick test. Just react with a emoji or whatever. I forget what they're called. What are they called? The things, the hands. Yeah, there you go. So if you're following me, put up a hand. Cool. Awesome. Cool. All right. Many to many is a little bit more difficult. I'm going to come back to many to many. I'm going to come back to normalization in the afternoon too. So what I want to do is do a demonstration on the how to use SQL Workbench. So all of these are the assignments on the platform. We'll talk more about data types in the afternoon as well, but these are all like Simple Blog, Likes, Yelp. All these have a video where they walk through the solution. So I'm not going to, have duplicate it. So, but I do want to do the users as a demo. So this is a practice assignment. Brian, did you have a question?
No, I
Oh, just
accidentally
okay.
everything.
All right, so I'm going to do a quick demo on this, and then we'll end for the morning. And again, I'll come back to many normalizations and all that stuff in the afternoon. Okay, so just to give you, and let me exit full screen. So SQL Workbench looks like this. Yours will look different. You have like a big header, but I just removed it. So take some time if you have this installed. There's a lot here. Okay, so it can be a little bit confusing as to how to do things and how to navigate. Notice that we have, we have this home. Sorry. There we go. This home button, right? So if you want to get back to this screen, click on this home button, because once I click on some other stuff, it's going to like windows pop up and it gets hard to navigate. So to get back here, this is where we're going to start. So to return here, just click on the home button. So this, the top button here represents all of our databases. So if I click here, you have to type in your password, and all the databases that we have are going to be under this tab. So just to go back and reiterate, these are our databases. The one with the little dolphin is our databases. This is our models. Okay. So we're going to start with the models. We're going to start by making ERD diagrams, but ERD diagram, I don't want you to confuse the ERD diagram with the database. Okay. So this is the map. This is the territory. Okay. So this is just sort of a representation of our database. So when we make our ERDs, we're not making a database. We're making a map of the database that we're going to create. Okay. Does that make sense? Any questions about that?
So it's kind of like just like a blueprint for when we actually want to do it.
Yes, exactly right. So this is the blueprint. This is the house. Okay. And we can, it's just a click of a button to go from blueprint to house. But I want you to make sure that changes you make here, like if you're working on a database and you think, oh, I need a column for email, right? You come back here and change your model, it's not going to affect the database you have, right? So you have to go through the process, and we'll go through that. Okay, so these are our databases. So to get into our database, we click here. All the databases, these are everything we're going to do in the class, but these will populate as we go forward. But getting back to the assignment, okay, so am I in the right place? No, I'm not. What happened? There we go. So the assignment is to create, and I'm not in the right place. Sorry about that. Let me zoom out a little bit. Get to users. So I'm going to do this one just as a demo. So first step is to create a new model. Okay, so to create a new model, we're going to go back to our MySQL workbench, and these are our models. Okay, so I'm going to click here, and I don't have a user. So to create a model, we're going to click on this plus sign right here. Okay, so click that, and it's immediately going to open up a bunch of windows. So if you want to, I'm going to minimize these. If I come over here, it's going to get rid of some of the stuff on the side so you guys can see what I'm doing. So first thing we need to do is name our database or our schema. MySQL, they use database and schema interchangeably. They make a distinction, but just know that for MySQL, for our purposes, a database and a schema are the same thing. So I'm going to rename this. Right now, if I don't rename this, it's going to name my database MyDB, which I don't want. I want to call it users. Right. So I'm going to double click this. I'm going to come in here and I'm going to rename my database users. And I think they want us to call it user schema. They don't care. Okay, I'm just going to call it users. So once I've done that, you notice that it went from being called MyDB to users. So once we've changed the name of our database, I can close this out, and I'm going to come up here to add diagram. Okay, so I click on add diagram, and this will again open up a new window, and this is where we're going to design our database. This is where we're going to create our tables, create our relationships. And again, this is just the map. We'll show you how to go from the map to the database a little later. Okay, so I want a users table, right? So to create a table, I come over here to the side, and there's this button right here. If you hover over it, it says place a new table. So I'm going to click that, and I'm just going to click it, and it just puts this box into the area where we design our database. Okay, if I want to add to it, I just double click it. Okay, then automatically brings up the columns for my database. Okay, so, and let me back up. Part of the reason I'm doing this is a user. We're going to make, I don't know, 20, 30, 40. We're going to make a bunch of users throughout this week. So I want you to do it this way every single time. Okay, so every time you make a user, come back to this video if you forget. Okay, because this is, I want you to, because I'm going to do some things that may not make sense initially, but I'm doing it for a reason. Okay, so I'm going to rename my table. So table names are always plural. Okay, so I'm always going to create, when I create a table, I'm going to name it the plural form of whatever I'm storing. So I'm going to call it users. Okay. Every table we create is going to have an ID. So the first column, and we come down here to add columns. So it's going to auto-populate user or ID users. That's a convention some people use. We're just going to call it just plain old ID. Okay. For data types, we'll talk in more detail about what data types are later or in the afternoon. But the data type we're going to use is int, which is just like the ints we've done in Python. Integer, it's going to store, I think it stores up to 4 billion. It goes up if we want to keep that many. We're going to check primary key and not null. Okay, so all of these different, don't worry about others. The only ones we're going to check are the primary key, which just tells our database that this is going to be our primary key for this table. NN stands for not null, meaning it has to be populated. Okay, there has to be a value there. And then AI it's not what you think, it stands for auto increment. So we're just going to click that. Okay, so that tells MySQL Workbench that we want our first column to be an ID, we want it to be an int, it's our primary key, and it's going to auto increment. So every time we add a new user, it'll go up by 1. Questions so far?
What was it? NN again?
So I'm sorry, say again.
What was the NN again?
NN stands for not null, meaning that it has to have a value. Any other questions? Okay. All right, so the requirements are we want to have a ID, which I did. We want a first name, last name, email, created at, and updated at. Okay, so next column, we're going to call it first name. First underscore name. It's going to be varchar. And again, we'll talk about what these mean. You don't need to worry about, there's only like 4 or 5 we're going to be using. So there's a bunch of them. So, but don't just know that when we create a characters, we're just going to use varchar and we can leave it at the default. So this means that we're going to keep up to 45 characters in this column. And that's it for first name. Okay, so last name is going to be the same. Call it last. Last underscore name. And varchar 45 is fine. Okay. Same with the email. So we're just going to call our column name email. Leave it as varchar 45. Okay. I'm going to add a password. Okay, we're not using password right now, but I just want to show you what to do when you're adding a password. Okay, so we're just going to call the column name password. And for the varchar, I want you to change it from 45 to the maximum of 255. Okay. The reason we do this is when we get into encryption, storing passwords, you never, ever, ever store bare text passwords, right? If somebody's password is kitten235, you're not storing kitten235 anywhere in your database. Okay, so we're going to hash and encrypt our passwords, so we'll need that extra space. Okay.
So that's giving it 255 characters worth of space.
Yes.
Okay.
Yes, but the varchar, the thing about the varchar is, and the reason it's called varchar is it will establish a variable length. So if a user only types in 2 characters, it's not going to create the space for 255. So it'll only take up the space that the user inputs. But yes, we want to have that extra space because when we hash passwords, you'll see that the hashed password is pretty long. It's longer than 45 characters.
So the varchar is not, it's giving it up to this amount of space, but not guaranteeing that it'll take up that amount of space.
That's right. That's right. There's another data type called char, which doesn't do that. If you allocate 45 characters, it'll take up 45 characters of space. So 9 times out of 10, if not 10 times out of 10, when you're storing a string data, you're going to use varchar. Okay, and then the last one, the password I added, you don't have to add this for this assignment, but I just want to show you guys this just to sort of drive it home. So we got first name, last name, email, I added password, and then we're going to add created at and updated at. So created at, call it the same, no capitalizations, call it the same thing every time. So it's created underscore at. And then the created, if I spell it right, created at. Now the data type is going to be the data type called date time. Okay, just like that. We don't need to, so basically this is going to stamp our user every time we create a user. It's going to basically create a timestamp for when the user was created. Okay, so the thing we need to add a default under the default expression column, we need to add some code. We're just going to say now parentheses. Okay, so this will automatically, when we create a instance of our class or we add a item of data to our database, it's going to automatically timestamp whatever time that user is added. Okay, so that's what the now parentheses does. Am I going too fast? Are we okay? Okay.
That's good.
Cool, cool. All right. Last one, updated at. So it's going to be the same data type. It's going to be date time. And for this one, and I don't think this is in the platform, there might be a better way to do this. This is the way I learned how to do it. So we're going to say now and on update now. Okay. So if we have something like blog post, right? And we want to give our user the ability to edit a blog post, right? The created at is forever going to be when the blog post was created. But if they go in and edit it, we want to be able to keep track of when they edited the post. So the created at and the updated at will tell us, okay, they created it 5 days ago, but like 30 seconds ago, they just made an update. Okay, so this is the syntax to add that. We say now, and then on update now. So basically that will just update the created at whenever a change is made. Questions?
Yeah, if you wouldn't mind just real quick going over the ID, that's just that's the key name, right? So that'd be okay. And it doesn't have to be named ID, that's just what we named it, right? Or
So that the convention we're following is we're going to call it ID.
okay.
Yeah, so I mean, there's no police that are going to say, hey, you didn't call us ID, right?
Mm.
It's, so the most common, I think, convention is just to give each table an ID and only call it ID.
Okay, and then that's where there'd be like the 1, 2, 3, 4, whatever. That would be where that goes. And that's why we have the like primary or the PK, the NN and all that selected. Okay.
Exactly. Exactly. Any other questions? Makes me nervous when you guys don't have questions.
This definitely isn't what I thought it would look like at all. Like databases, like where you like looks like a little, paint, Microsoft Paint or something out here.
Right.
Interesting.
Now, so there is a way to do this using just bare SQL, but trust me, you don't want to. It's a lot of code, a lot of just tedium, and whenever you're typing out code, you're prone to errors. So this is an amazing tool. Okay, so now I can close this table, right? I can get back to it if I want to make a change. But if I close it, I get my ERD diagram. Okay, so this represents a table in my database. So I have a users table, which will keep track of any users that get added to my application. Okay. Jesse, you have a question?
I do not.
Okay.
Did you
Okay,
do
so-
something Oh, sorry.
No,
I
no,
was
man,
just gonna ask, did you do something to get those like little boxes on your screen? Mine, I've been like following along. Mine, like I've just just like a white background.
these what box? You mean?
No, like how your whole diagram itself has like a bunch of like boxes on it. Like you see
You talk
Uh,
about the grid.
yeah, the grid,
Little
how it's gridded.
diamonds.
Oh, this. Mine just came that way. I think there's a way to
Huh.
toggle it.
I'll look for it later. I was just wondering.
Yeah. Okay, so what I want to do now is this assignment's done, right? You're cool, like this is it. But I want to just show like how to add a second table, just to sort of explain these other tools that we're going to be using. So I don't know, what should our user have?
Post history or something, or like likes or something.
Yeah, let's do, likes could be like a many to many, which we haven't talked about yet. So I'm going to just do post. So let's say, or I'm sorry. So you guys, what do? I want to make a post. I want to keep track of posts. So what do I name my table? Do I name it post?
ID. Right?
Well, so if I haven't named my table.
You name it post but plural.
Right, posts plural. So always pluralize your tables. So I'm going to call it posts. And I want to give it an ID. So I'm going to name it ID. The data type is always int. Whoops. Don't you yet? Go away. Oh, all right, whatever. So my ID, and it automatically checked primary key and not null for me. But what else do I need to check to make sure that this is a proper ID or primary key?
The AI.
Right. So we need to auto increment. So that's it. Those three boxes. Every time you create an ID, make sure it looks exactly like this. Okay. Now I'm just going to have the post consist of content. And this is just arbitrary. You can call it text. Well, I wouldn't call it text, but words, whatever, right? You just name the column something that's logical and makes sense. And one of the other data types we can use is text. And text is just a little bit, not a little bit, but a lot bit version bigger of the varchar. So if we want to keep something more than 255 characters, we want to use the text data type. Okay. And that's it. That's it for our content. So what else does every table have to have?
Created and updated.
Yeah. So we need a created at and an updated at. And what was the data type for created at?
It's like date or something like
Date
that.
time.
Date
Date
time.
time.
So date will just keep a date, and date time will keep a date and a time.
Wait,
Make
the
sure you
data
spell-
or
You
okay.
spelled date, right? Sorry about that. So date time. And then how do we make sure that the current time that this is created gets stored?
Now, right?
Yeah. Let me try to move this up so you guys can see. Okay, so yeah, at the created at, I want to add now, parentheses, and updated at. Same thing, date time. And to make sure we log when and if an item is updated, we want to say now. And what?
Data.
So we would say on update.
Oh, on update.
So as soon as that's basically telling MySQL, whenever this is updated, I want you to re-establish when it's updated. So first time we create it, we just say now, right? So when we first create a content or a post, created at and updated at are going to be identical. But if I come in and I edit it, I want to indicate when it was edited. So I tell MySQL, whenever this is updated, so on update, replace the timestamp with when it's updated. Okay. And that's it for our post table. So it just has an ID, whatever variables we want to store. So I'm just going to store content, but you can store as many as you want. and then create it at and update it. So if I come up here, why won't you close? Oh my God, it won't go. There we go. So I want to establish a relationship between users and posts. Okay, so in order to do that, we want to come down here. We have these arrows basically that will establish the relationships for us. Only use the ones that have a broken line or the dashed line. Don't use these. Okay, so these are identifying relationships. These are non-identifying relationships. And basically the difference is this puts an extra constraint on our data. So if we use the solid line, then it won't let us create a user unless we already have a post, and we have to declare or create our variables in a certain order. So don't only use the broken lines. Once you get more advanced and you want to put constraints on your data, you can use these, but for our purposes, to make our lives easy, just use the broken lines. Tyrone.
Isn't this just like the blueprints though? Doesn't this not actually, aren't we not actually writing anything right now?
We're
Like,
making the blueprint, but the beauty of this is once we establish the relationships and I'm done, like I've decided what my relationships are for my data, I come up here to databases, click on forward engineer, and it will make the database for me.
Oh, okay. So,
Yeah, so
it,
this
like, actually builds it. Okay.
yeah, it actually builds it for you. So when we tell it, I want the relationship between users and posts to be whatever I want it to be. I want a user to only be able to have one post. Then I would use one-to-one if I want a user to have many posts, right? So we're going to use basically these two. Don't touch the bottom ones for now, okay? So does a user have many posts generally in like a blog type application?
Yes.
Yeah.
So to establish that relationship, we want to come down here and we'll see where it says 1:, is that an M? Whatever it is. It's with this, the broken line with this kind of angled, it's called the crow's foot. We're going to click on this to establish our relationship, just like we click to make a table. We click the button, it highlights. We go start with the many. So whatever the relationship, whichever one is the many, we click that first. Then we click on the one that has the relationship. Okay, so start with the many, click on the one that has the many relationship. Okay, so this diagram basically, this is called the crow's foot here. This just shows that this is the many and this is the one. Okay, we'll talk about many to many this afternoon. Okay. Now, there's one last step. Notice that when I established this relationship, it pre-populated this user's ID column. So I want, our convention is going to be to change that to singular. So whenever we have a foreign key, which this is, right? This is the foreign key that's going to link posts to our users. We want to be sure to come in here, double click the table, scroll down to that column and change it to singular. Okay, so just take out, instead of user's ID, it's user ID. And that's just the convention we follow. And come on, how do I get rid of this? I don't think it's there. Yeah, I think if I just go away, it'll go away. I'm having it, it's like things aren't deleting or something. Okay, it's fine. All right, so that's it. So that when we want to establish a relationship, that's basically the steps. Now, the last thing you need to do, we go back to the instructions. And again, you don't need the posts. The only thing you need is the users. I just wanted to show you guys basically how to set up a relationship. Now, the last requirement is take a screenshot of the ERD and upload the .png file. Now, the good thing about MySQL Workbench is it will do it for you. You just need to know where to look. So if you come up here to File, yes, to the File tab, scroll down to export. Okay, so start with the file tab, go down to export, and there's this option to export as PNG. Okay, so you don't need to worry about taking any screenshots or anything like that. You just export as PNG, decide where you want to save it. I'm going to save it to my desktop just so we can find it later. And you can name it. I'm just going to call it users. And I'm going to save it. Now, if I go to my desktop, it's right here. Okay, so now we have the PNG automatically generated. So you can just, when you go to submit your assignment, just go down to the submit, drag that in there, and you're done. Okay, that's it for the morning lecture. Let me stop sharing.